In this video, we begin one of the most important steps in public health data analysis, data cleaning. Real-world data is rarely perfect. It often contains missing values, inconsistencies, and variables that need to be transformed before analysis. Learning how to clean data properly ensures that your results are accurate, reproducible, and trustworthy. First, we load the packages we need. We'll use the DPOIR package, which is part of the tidyverse. It provides intuitive functions for manipulating and transforming datasets. Then we load library, readr, which helps us import data files like CSV files. We use read underscore CSV to load the file into R and store it in an object called nchains. Before cleaning, we must understand the structure of the data. We examine the first few rows and inspect variable types to identify potential issues. Running the head function shows the first 6 rows so we can quickly see what the dataset looks like. Then next we run str to show the structure of the dataset, including variable names, data types, and a preview of values. Finally, we run the summary function, and that gives us summary statistics like minimum, maximum, mean, and quartiles for numeric variables. Now let's talk about handling missing values. First things first, missing data is extremely common in public health datasets. In R, missing values are represented as NA. We can count missing values, remove incomplete observations, or handle them strategically depending on our research question. Removing missing data without thought can introduce bias, so this decision should always be documented. So when we run colsums is .na, R counts how many missing values are in each column. This is very useful because missing data can affect analysis. If we want to remove all rows that contain any missing values, we use na.omit. We store the cleaned version in nchains underscore complete, but sometimes we only care about missing values in one variable. For example, if we only want to remove rows where BMI is missing, we use filter is .nabmi. This keeps only rows where BMI is not missing. Next, we'll talk about selecting and filtering variables. Often we do not need all variables or all observations. We can select specific columns for analysis and filter observations based on conditions. For example, we might analyze only adults over 18 years of age or only non-smokers. Filtering allows us to focus on specific subpopulations. By running the command select age, sex, BMI, smoker underscore status, we keep only the variables we care about and store them in nchains underscore selected. This makes our dataset smaller and easier to work with. To filter observations, for example, if we want adults only, we can use filter age greater than or equal to 18. If we want only non-smokers, we filter where smoker underscore status equals no. Filtering helps us focus on specific groups in our data. Now we'll create new variables. Creating new variables is central to public health analysis. We may categorize age groups, calculate body mass index categories, or derive new indicators from existing variables. The mutate function allows us to add new variables while preserving the original dataset. First, we create age underscore group. If age is less than 18, we label it child. Otherwise, we label it adult. Then we create BMI underscore category using case underscore when. This lets us classify BMI into categories. Less than 18.5 is underweight, 18.5 to less than 25 is normal, 25 to less than 30 is overweight, and 30 or higher is obese. After creating these variables, we use head again to preview the updated dataset. One of the strengths of R is that every transformation is written in code. This makes your workflow transparent and reproducible, a cornerstone of modern public health research. Using the pipe operator, we can perform several steps in one sequence. We start with end chains, filter for adults, and then select only the variables we want, including the new BMI category. This creates a cleaned dataset called NAChains underscore cleaned. Chaining makes code cleaner, easier to read, and more efficient. And that's it. In this video, we learned how to load data, inspect a dataset, handle missing values, select variables, filter observations, create new variables, and chain multiple operations together. These are core data cleaning skills you'll use in almost every data analysis project in R. In the next video, we'll begin exploring and summarizing data to generate descriptive statistics. This is where cleaned data becomes meaningful information.